And good morning, all, or good afternoon, evening, wherever you are attending from the globe. I'll share my screen. Thank you for taking this time to listen in and log on to this webinar today. And thank you, Randolph, for hosting this and giving us the opportunity to speak. So a little bit about myself and SKANWEAR, and the presentation today is, over the years, we find so much in the industry. There's so kind of little knowledge or understanding at the grassroots of the issues around arc flash, electric shock, and the general working safely around electricity. So I hope to try and make some things clear today. I know we've got some more technical, in-depth presentations later on in this webinar today. So hopefully those that are more technically minded, if they don't get what they need in my presentation now, they'll get that in some of the other presentations later on. But hopefully what I'm going to show you now will kind of give you some ground understanding of why you need to be safe around electricity. So moving on first, so the agenda for today is what is an arc flash in basic simple terms, and then what is electric shock, electrocution, make the clarity between those two, and then when do arc flash incidents occur, why should we have electrical safety, kind of why should we be safe around electrical equipment, and then what is arc flash and shock PPE, and then how do you wear it, and then ultimately speaking the contact details for us if you need to reach out to us after this this webinar in the future. So first of all, so what is an arc flash? So quick clip here to show you this arc flash, caught on a webcam, so phenomenal footage of this arc flash. You've got these two guys here. Now these guys are wearing arc flash PPE. So what you'll see as this arc flash develops is these guys, they're kind of able to look back at what could have been, you might say. So they're working away. You can see they've got a full arc flash clothing on. They have gloves on. They have the face protection, head protection. So in essence, they're working in a relatively safe condition. But as you can see now, that's the arc flash. Okay, so it goes into a replay. I'm going to skip on from the replay. One of the main things I want to talk about is the actual development here with the arc itself, and then the shrapnel that you can see as those sparks are ejected out of the arc flash itself. So an arc flash takes place when the oxygen surrounding the arc heats and explodes and creates the following hazards. So you get the blinding flash of infrared light and ultraviolet light. You get the high heat, which is 34,000 Fahrenheit, and then you get the molten metal from conductors or metal cladding, and then obviously with that you get the high noise levels. When we talk about arc flash clothing is protecting you initially from the actual heat that's generated with the arc itself, but the secondary protection with the arc flash clothing comes from molten metal. So if any of you are working in metal foundries, you'll know that molten metal carries a massive amount of heat. When it starts to cool down, it sticks very easily to garments, and you've got a secondary heat source stuck on the garment, burning through the fabric to the wearer on the inside. So looking at some statistics here, so arc flash clothing is designed to reduce the fatality to a 3rd or 4th degree burn. Now, turning the clock back just a little while, a few years, you've very rarely heard of 4th degree burns, because generally speaking, 4th degree burn was a fatality. 3rd degree burns you heard of, but a lot more these days. Burns units, they do a phenomenal job, and so we still do see survivors from 4th degree burns. But basically, 3rd or 4th degree burn, you're reducing those to a 2nd degree burn, and 2nd degree burn to a 1st degree burn, or no burn injury at all. So there is no known fatality of someone being involved in an arc flash and wearing arc flash PPE is always due to the absence of arc flash PPE. A bit later on, I've got a short video clip to show you kind of what happens when you're not wearing arc flash PPE over against wearing arc flash PPE in an arc flash situation. And one of the things to look at here as well is when we do arc flash tests on clothing and on fabric, you may be well aware of this already, but the clothing is given an instant energy value, either ATPV, ESA BT50, or if you're in Europe, to the side of the Atlantic Pond, you also have now an ELIM value. But those values, the ATPV and ESA BT50, are designed to give you the instant energy rating of the clothing at a 50% probability of the onset of 2nd degree burn. So we're trying to keep this, the heat passing through to the body under the 2nd degree burn. So that's moving to 1st degree burn, and that's your sunburn that you'll get on a hot day when you've not worn any sun protection. So electric shock, electrocution. So some of the times the terms are kind of mixed up. Really clear. Electrocution, electric is the electro part of things. The cution is derived from execution. So electrocution is, normally speaking, when somebody passes away as a result of receiving an electric shock. Electric shock is obviously when someone receives the actual charge, but they're still alive to tell the tale, you might say. So really, really quickly, electric shock is a term used when a person survives. Electrocution referred to when someone passes away from the incident. So the risk of this current interfering with the nervous system, which controls muscles, often sudden when it's a spasm. And obviously in the case of the heart, which is your largest muscle in the body, it goes into cardiac arrest, and then obviously you know what heart attacks do. Other muscles may become paralyzed, often organs and muscles are burnt, which is one of the main points that they say you must always go to the accident emergency services after electrocution, because there's nothing, you may feel fine in person, but there's no telling what's going on inside the body. So when do Arc Flash incidents occur? So they can take place anytime, wherever there is live or potentially live electricity. So some people say, well, you've got to be doing something stupid to be involved in an Arc Flash. Well, not necessarily. So we've had situations in the UK where people have been cleaning in switch rooms, controlling environments. The gear has been faulty. It's not being picked up. It's arced. And as a result, cleaners, you would generally think are the kind of lowest category in terms of being Arc Flash PPE, and then you're badly burnt as a result of that equipment kind of self-destructing. So we always say, if it's a live, a potential live electricity situation, wearing some form of Arc Flash PPE as a base level is better than wearing nothing. And I'll see the video later on, we'll explain this to you. So, but some of the main situations there are when there is a system fault, when the system isn't in normal operating condition. Now, normal operating condition is kind of like a key fundamental part of NFPA 70E and the CSA Z416 is to when you're, how can you say the equipment is in its normal operating condition? Generally speaking, it's if you own the facility, you're working on your own equipment, and you've got a full service record of how that equipment's been maintained and when it was last operated. For the contracting world, often that kind of information isn't readily available, especially if a site is new to you. So you've got to then take it away from that normal operating condition and treat it as though there could be something wrong. So when carrying out isolations or re-energizations, fault finding, racking out breakers, there's another issue there. When you're working with panels or doors that are open due to human error or incompetency, and that's kind of probably the big kind of elephant in the room. And then when the system is live, you're thought to be dead. Crucial part of this, and it's why I talk about later on about proving dead. And then, or when you know it's live and it's supposed to be, obviously there's a high risk of Arc Flash because the system is live and you know it's live, but it's making those precautions to make sure that you're working safely if the system is still live and it can't be isolated. So why do we have electrical safety? So electricity is invisible. It's got no smell. So experts will tell me that it does have a kind of smell, but it's not the same kind of smell as like if you had a gas leak, you would soon smell you've got a gas leak. You know that it's the area is then unsafe. Electricity, there's no smell and it's invisible. You can't see it, so it strikes without warning. There's great potential to seriously injure or kill. We've talked about a few of those instances just now. And every company has a duty of care to its employees and its contractors. So we find a lot of situations, a company will employ a contractor because they're kind of scared to go into the facility, work on the equipment. They employ a contractor saying it's your responsibility. It's not. It's the company's responsibility to employ that contractor to carry out their work safely on their behalf. So they become responsible for that, for those contractors working on their site. So everyone is exposed to electrical hazards, not just electricians, as I mentioned before, the cleaner in the switching control room. Report all electrical shocks and near misses, because if you don't do that, the next one might be fatality. All employees exposed to electrical hazards should receive electrical hazard training at the commencement of their employment, and obviously also regular refresher training, so we know what it's like. You do training for a particular task, and over time you take shortcuts. Take, for example, driving a motor vehicle. As soon as you start driving that motor vehicle, when you've taken the day you've taken your exam, your test, you'll find that the things start to creep in. You don't use the signals, etc., and you take things easier. You find a shortcut. Exactly the same thing. Humans, we're wired up to look for shortcuts, easy options. Just going to show you this quick video, and hopefully you can understand him. He's Scottish, but he's living out in Australia, so Australians have a hard time
for
listening to him.
18 years now, and I'm very confident in what I do, and I still ended up in hospital. I've got up that day the standard day, not thinking anything of it. I says, like, I'll bounce in and do that power quality assessment we had to do. I'd assessed the work to be done live, and I was very confident of what had to get done. It was possible to do it live. All I need.
Well, I'm going to move on from that, but basically speaking, Mark's story, you can see it's on YouTube. And one of the main things about it is he was working live when he received a really severe arc flash. So sadly it's not working because you can see some of the actual visuals are pretty graphic and what happened to him as a result of his arc flash. One of the main things that I point out in this story of Mark's is he was wearing shorts and t-shirts and insulating gloves. He was working live. So whenever you're working live, there's always a potential, as I mentioned earlier, for arc flash or electric shock. So his rubber gloves were there as a crown protection for electric shock. If there was to be an arc flash, the clothing he was wearing was nowhere near where it needed to be for his arc flash. As a result, his body took a massive amount of the arc flash, and as a result, he was hospitalized for a long period of time with some pretty horrific burns. But fortunately, he lived to tell the tale, and he's sharing his story to make sure others don't fall into the same situation. One of his main key points is, don't work live if you don't have to work. If you don't have to work live, don't work live if someone's pressurized you to work live. It's always safer to isolate the equipment, turn it off, make it dead, and then carry out the work. Obviously, the actual process of isolating equipment is classed as live working, but ultimately speaking, making sure when you're working safe. You're not just taking general risks. So PPE is your last line of defense. So you can see on the slide there, this is one of our jackets, and after an arc flash test. So it was an arc flash test of, I think it was 35 cal with an open arc test, not the European box test. So basically, number one is you've got to eliminate the hazards and risks. What are the hazards? What are the risks? Can we eliminate those? Kind of go through those before you start doing work. Reduce the risk of substitution, reduce risk with isolation, and then reduce risk with engineering. So engineering changes or systems of work, put those in place rather than just going headlong into the situation where there's a possibility of arc flash or electric shock. And then so number 5 is use PPE. Now, people will say, well, if I put all the other things in place, I put number 1, 2, 3, and 4 in place, I don't need any PPE. Well, there's a high chance that you probably still need some kind of PPE. We talked before about human error. If there's still a human element in the work that you're going to be carrying out, bear in mind, human error, it does happen. It's a real thing. It's not a myth. Okay, so safe isolation. So isolating supply, can this be done remotely? If you can run remotely, it removes the wearer or the person from the actual point of isolation, from the area there's a risk of arc flash. It removes them out of the way of that situation, that zone. So if something does happen during the isolation period, the wearer or the person operating the equipment is right out of the scope of the arc flash should something go wrong. Lockout, tag out. So many stories. People not locking out, tagging out, doing some work maybe around the back of the panel. Someone coming into the room. Why is this switched off? Let's turn this back on again, put the power back on again. So lock out, tag out, and then thirdly is prove dead. So many situations we see proving dead isn't taking place. And if a proving dead isn't taking place, you come to remove a panel, to do some work on a panel. Unless you've proved it's dead, that panel is still live. And so many injuries, so many fatalities we find is when people haven't proved dead, open up panels and start to work on panels that are still live. And as a result, you get either fatal or really critical consequences coming out of that. And obviously, certain systems are set up to already manually earth, but otherwise, you can apply the earth yourself. It gives you a backup in case something gets energized in the process. So what is arc flash and shock PPE? So it's the last line of defense, as already discussed, is to make sure that when all checks have been done, in case something isn't functioning quite right or live working can't be avoided, you're still protected. So you're protected from the onset of second degree burn, which we talked about before. So first degree burn is kind of like if you've had been out in the sun and got a bit of a sunburn, that's the first degree burn. Second degree burn is when your skin starts to blister. Depending on age, fitness levels, the percentage of the body burn that gets the blisters depends on your actual chance of survival. So your body kind of goes into a state of shock, and it's making sure that your actual body can deal with that on a second degree burn, which is why the clothing is done at a 50% probability of the onset of second degree burns. The clothing needs to be comfortable, so it can be worn at any time. clothing that's uncomfortable, it kind of tends people to say, I'm not going to wear this clothing because it's uncomfortable. It's only a quick job, I'll do it without the clothing. It must have an ARC rating so that the wearer is fully aware of the protection levels that the clothing offers. So that if the equipment is labeled correctly, they can make sure that the clothing they've got either matches or exceeds the risk that could be generated within the equipment itself. So it must be tested in a certified product. Don't rely on a fabric-only certification, because a fabric-only certification isn't going to tell you if the garment has been tested as an actual full product. So it may be very well having an Arc Flash garment, receiving an Arc Flash, but if you can't get out of that garment and you're trapped in a hot garment, the heat will still continue traveling through to the garment on the inside. So make sure it is a fully tested and certified product. And obviously, at the end of the day, it's another measure to help saving lives, because without these kind of measures in place, we still lose lives, sadly. So this was a video I talked about before of why you would wear Arc Flash PPE or not wear Arc Flash PPE. So you may have a situation where you think, you know, I don't need Arc Flash PPE, I'll just wear some general PPE. We've talked about human error. We've talked about systems where the actual equipment might be faulty. It might arc on its own accord without any actual human interference, but you might be in that vicinity. When you're not wearing Arc Flash clothing, you'll see from this video here now what happens in that situation. So the left-hand side, light grey top and dark grey pants are 12 cal arc protection. On the right is a polycotton polo shirt and pants. So that was a 14 cal arc. You see on the left-hand side, the front of the garment is charred, but on the right-hand side, the garment's engulfed in flames. So many times we see situations whereby people haven't worn Arc Flash PPE, they've received a really bad arc, but their burns are horrendous and way, way more than the actual Arc Flash itself would have given them. And that's because the clothing is caught on fire. It then brings another situation where somebody has to put you out. So you imagine you're working with another colleague, you're in Arc FR PPE, and the other colleague isn't. You know, you might be the person that's trying to put that squealing guy out if the Arc Flash takes place and that guy's burning. So bear that in mind. So how to wear Arc Flash PPE? We see so many situations where people will say, I have an Arc Flash coverall, you know, I'm good, or I have an Arc Flash shirt and pants, I'm good, I don't need gloves, etc., etc. So Arc Flash face shield or hood, balaclava, etc. Rubber insulated gloves or Arc Flash rated gloves, depending on what the work's being carried out. Arc rated balaclava or hood, as I spoke about. Full Arc Flash clothing, but as you'll see on the right hand side, zips to the top of the collar or fastened so there's no exposed collar area. Arms fully covered, safety glasses, and obviously leather shoes, rubber soles, or arc shoes, or dielectric footwear. All those sort of things is making sure that your whole body is covered and protected from either electric shock or from arc flash. So these are our contact details. So Bev McPherson, she's my colleague in North America, based just outside Chicago. And you can see her contact details there. And then myself, I'm the Global Technical Director for SKANWEAR. And then as a business, we're a global entity. So I'm talking to you today from Doncaster in the UK. We're up in the northeast, and that's our headquarters. But you can see on the map there, we have our facility in Schaumburg. We have a facility in Germany, in Sweden, and also you might see the little dot on the edge of Australia. We have a facility out in Perth. So we have a global coverage, global PPE, and we're here to offer safe systems of work and PPE for companies globally, with the ultimate objective in saving lives, making sure that the end user is prepared and equipped for the work that may be carried out. So with that, I want to thank you all and wish that you all go home safe. If you're out in the field today, go home safe, and thank you very much for your time. And if there's any questions now, I'll try and run through and answer those for you all.
First up, will the clothing be designed to minimize hot metals sticking into it?
So all Arc Flash clothing, as part of the test of Arc Flash clothing, they're obviously tested in an Arc Flash situation. So you saw the two garments that was in an Arc Flash test. The Arc Flash itself will create the heat. You'll then also get the molten metal. So the clothing, any Arc Flash clothing is designed to withstand molten metal as a result of an Arc Flash. However, you could also get clothing which is designed for steel, iron, aluminium, foundry, etc., which will protect not only against the molten metal in those situations, which is probably going to be far greater than what you would get in an Arc Flash, but also that are Arc Flash rated as well. So we have situations in Europe. We have fabrics that we can use in the UK and Europe and in the USA, which meet all those standards. So they meet the standards of molten metal splash, and they meet the Arc Flash standards as well. So you can have a combined garment if you're working in foundries. But as a general rule, all Arc Flash PPE has by nature of the test, has an ability to withstand a certain amount of molten metal.
Okay, next question. What kind of clothing is best to wear under PPE? Oh,
So
I guess that means cotton or nylon.
Yeah, so if you're wearing Arc Flash clothing, so you're wearing a shirt and pants or a polo shirt, coverall, etc. When you're wearing clothing underneath, so we talked about the actual heat that passes through a garment. We're trying to limit that to a second-degree burn when it hits the wearer. So we're making sure that any garments that are worn underneath there are non-melting fabrics. So things like cotton, wool, silk, if you wanted to, they're all fine to be worn underneath garments. What we're saying is, don't wear your polyesters, your nylons, your acrylics, for example, underneath the garment, because there's potential then for those to heat. And if, for example, you have a garment, I don't know, rated at 12 cal, but you haven't worked out the instant energy properly, or you don't have a proper calculation or risk assessment, and the arc is greater than 12 cal, more heat will actually pass through the garment itself. So it's being mindful of, and it kind of goes back to wearing that PPE correctly. If you wear a garment that's open and you've got a cotton undergarment, there's still a chance for that cotton to ignite if it's exposed to the actual raw Arc Flash in its own right.
Does the undergarment, cotton undergarment, under the Arc Flash rated clothing, does that provide additional protection?
It doesn't provide additional protection from an Arc Flash, but cotton is quite a good insulator. So it would insulate the body from a bit of the heat created by the Arc Flash, but it's not to be used as part of a layering concept to actually increase the Arc Flash value of the garments on the outer. Whatever you're wearing, your kind of last layer that you're wearing of Arc Flash PPE against the body, if you're wearing something underneath that, you've always got to go by the actual rating of the outer garment rather than adding a bit extra for an undergarment that might be in cotton.
Talk about layering for a minute. What is the benefit of layering Arc Flash PPE?
So layering PPE, one of the first kind of fundamentals of this is air. So air is an insulator for heat. And so when we test Arc Flash garments, the fabric itself is tested right against the conductor. So we're picking up how much heat transfers through the fabric, but with no air gap. As soon as you put two pieces of fabric together, you've got an air gap in between those two garments. And then when you wear a garment in real life, you're generally going to be wearing a garment that's a bit further away from the skin than what the fabric would be in the test house when they're testing against the actual, in the actual Arc Flash itself. So when you get an air gap, that's added as an insulation. If you've got two layers of Arc Flash clothing, the outside tends to become the sacrificial layer. So that kind of takes the total force of the heat. It takes the force of the actual molten metal being ejected from the Arc Flash itself. And that outer layer is often the layer that will then hold, or it will char really badly, but it will take a lot of the heat. The second inside layer then, because there's been an outside layer that's taken the main force, then you've had the air insulation gap. And the second layer on the inside then is then further protection against the Arc Flash itself. So generally speaking, we see a big jump in the Arc Flash protection as soon as you start to layer fabrics. And then there's also different situations, whereby if you've got an ATPV fabric or an ESA BT50 fabric, as to where you put them on the outside and inside of the garment, as to how well the performance increases when you have 2 or 3 layers of fabrics.
So if you're wearing a 4 cal shirt, and then you're wearing coverall on top of I say 12. So is that really, do you have a really protection value of 16, or is it more than that?
So we do a lot of testing ourselves. In the main, we find you can pretty much add the ratings together and you'll exceed that. But 1 or 2 situations where you can't do that. So before we've tested 2 fabrics at 10 cal, you would expect they would achieve 20 cal or over, and they haven't, they've achieved like 18 cal. So you can't always use it as a rule to say that if you add the numbers together, this is what you get. Mm-hmm. In some instances, you can kind of get more than the actual sum of the 2 parts. And in other cases, you'll get less. So a lot of the time it will depend on how the fabrics react in an Arc Flash situation when the arc is increased. So you imagine you have a 10 cal fabric and you put another 10 cal fabric behind it. the fabric at the front has only withstood a 10 cal arc in its first test. If you wanted to increase the arc flash to 20 cal, that first fabric is going to kind of almost disappear in the arc flash. So then you've got to make sure that 10 cal fabric behind that is going to have enough protection still left in the fabric after the first layer has kind of disappeared in the arc flash. So
Okay.
there's not a straight down the middle answer, I'm afraid. It has to be done per garment, per fabric.
That's right. Okay, great. Okay, next question. Does Arc Flash clothing quench work perfectly?
So Arc Flash clothing, so if it's certified for Arc Flash, it can't keep on burning. So in the USA, the tests are pretty straightforward. You have the ASTM F959 or the ASTM F1506. In Europe, we have an EN standard, which is 14116, and that's a flame spread standard. So flame spread has 3 different indexes, and they actually mean different things within the test itself as to whether how long it burns for, what surface area it burns, does it drop molten debris, etc. But in the ASTM route, which is a very, very straightforward flame and arc tests in terms of their deviation, you might say, it's very, very clear that the garment has to self-extinguish really quickly. So if the garment is tested as an ASTM F1506 tested garment, tested fabric, it's proof that the garment, if a flame is applied or an arc flash is involved with the garment, that any flames will extinguish within 2 seconds.
Okay. Mark wants to know, or Mark's saying, I prefer to avoid leather shoes for personal reasons. Is there an alternative?
That's a good question. So ultimately speaking, there are FR shoes in the marketplace that aren't leather, and they use other FR fabrics. They're not super popular. There's not many companies that make them, but there are other shoes in the marketplace that would offer protection that aren't leather, but they are few and far between.
Are there fabrics that can be worn over the shoes, like covers over the shoes?
So you can buy Arc Flash over boots that basically are literally like the Arc Flash coverall, Arc Flash suits, and they will go over your boots. If you're wearing normal boots or trainers, etc., the safety trainers, you can pull those over the top, and you've got full coverage from the Arc Flash. Yeah.
Well, then maybe that's the solution. In the standards mentioned, is PPE required when just operating breakers and switches, not working on energized equipment?
Yeah. So if you're operating breakers or switches, there's obviously still a potential for Arc Flash, depending on the situation. So it's ultimately speaking, it's knowing what you're working on, and then ultimately speaking, knowing if there's a risk with that particular switchgear. So I talked before about normal operating condition. If you know the equipment is normal operating condition, then this is safe to work on. You could work on it in any clothing, and you'd be safe. But it's understanding what's the likely instant energy of a particular switch or breaker, and then ultimately speaking, what is the probability that it could arc whilst you're operating it. And it's making sure that you're fully aware of the equipment you're working on. Don't take the assumption that everything's safe. It's always better to be cautious than to be sorry.
That's right, and it's worth reminding that both NFPA 70E and CSA Z462 recommend workers to work on de-energized equipment.
Correct.
That's the first recommendation. It's always preferable to work on locked out, tagged out, de-energized equipment.
Correct, every time. Yeah.
That's the safest thing. Okay, let's see. Are SKANWEAR products CSA certified to be used in Canada?
They're not CSA certified at this very moment in time, but they are going through certification, and we hope in the next month they will be CSA certified for certain products. So some of the CSA products that we will produce are a high visibility orange, and we've not finished the certification for those yet, but any garments that are not high vis are going through CSA certification at the moment.
Okay, next question. Would you agree personnel should have Arc Flash protection in mind in terms of their undergarments. We talked about that earlier. For example, I see many people wearing a common white cotton undershirt beneath their arc-rated long sleeve shirts. The undershirt is cotton, but oftentimes laundered poorly in that it is treated with bleach and fabric softeners. Is this likely to be exposed around the neck and very well could result in igniting it? Yes or no?
So in a classic example there, we're talking about shirts. We're talking about the fact that if you're wearing a cotton t-shirt underneath it, if you're wearing a shirt and it has a top button, fasten the top button before you ever start to operate the equipment. Because if the top button's open, the cotton is exposed, there's then a risk of the cotton igniting. Cotton will ignite, it will burn. Obviously not as prevalent as something like polyester would do, but there's still a risk. So any undergarments like that, if they're not FR, make sure they're completely covered up. At the end of the day, for a short period of time, you might need to cover it up. It's better that than having a burnt esophagus.
Okay. Next question from Stefan. What is meant by the statement on one side that employers have a duty of care to contractors? This seems contradictory to requirements in Canada. Contractors are hired to bring expertise and knowledge that owners don't have.
Yeah, so I'm not completely familiar with Canadian employment standards, but I know in the UK and Europe, and I'm pretty certain it's the same in the USA, is that as a business, you are responsible for the contractors you bring on site. You may sign up contracts whereby the contractor takes responsibility for something. If the contract is being done in that way, that the contractor is fully aware that they're taking on the responsibility for their own health and safety, and it's not being covered by the actual the main company, then that's clear. But if it's not in place, then the main company hiring the contractor is the one that takes responsibility for any work the contractors carry out.
And I would add,
it may be different. So
yeah, I'd add to that a lot of companies require their contractors to be certified Arc Flash trained, that they will comply with Arc Flash standards. You know, they agree to the standard first, and then the company will supply a minder or a watcher to be with the contractor to make sure that the contractor complies with the regulations.
Yeah, so we would have it in the UK. We have a thing called RAMS, kind of a scope of work,
right?
Risk assessments, all built into one, and then that would be approved by the main business before the contractor actually starts work.
Okay. Are contact lenses a risk while wearing the appropriate Arc Flash PPE in the event of an arc?
I've not heard of it being a risk. Ultimately speaking, if you're wearing proper face and eye protection in the event of an arc, that will actually stop the amount of heat being generated coming through to the body. They may feel dry afterwards, but I've not heard of any issues with contact lenses and arc flashes, except obviously where it's not being worn.
Yeah, sometimes it's overlooked that hearing protection is also of great value.
Yes,
part
correct.
of the PPE overall outfit, correct?
Yeah, correct. And when we talk about ear protection, the in-ear canal protection rather than the external ear defenders.
Is that right? Okay.
Yeah.
What type of head face protection and ratings do you have?
As a business, we have up to 65 cal hoods, 40 cal hoods, and then we have a various different helmets and visor combination with balaclavas, ranging from 12 cal through to 28 cal. But then we always recommend when it gets over 12 cal to be wearing a hood as per NFPA 70E, rather than wearing just the helmet and visor and balaclava combinations.
Okay. What is the purpose behind having to wear PPE when doing infrared thermography testing? This will be a good question for Greg Stockton later today.
Yeah. So we recommend as a general rule, if you're working on electrical equipment on a frequent basis, is to be wearing at least day wear Arc Flash PPE. And then obviously, depending if you're doing infrared with panels open and panels alive, There's always a risk that when you open a panel, for example, if there's something inside the actual panel itself, which could then cause the arc, if there's dust in there, for example, when you open the panel, it kind of creates a turbulence within the dust. Obviously, the last thing you want is that dust then setting off a three-phase arc. So we always would recommend day wear as a precaution, but then as soon as if you're opening panels up and you don't have the infrared windows within the panels, and you obviously, because you're opening the panels and there's live equipment, there's always a heightened risk.
Okay, and the last is a comment from Mohammed. Arc flashes happen so fast that employees have zero time to react. We have only one option: to use flame retardant clothing and use rubber insulated tools. We must prevent the accident instead of suffering the accident. Yes, prevention is, an ounce of prevention is worth a pound of cure, correct?
Correct. Yeah, and like I said before, rather than just relying on PPE to do all the work for you, look at the system and see what can be done with the system to make things safer and reduce the reliance on PPE, or reduce the actual amount of PPE you need to wear. So,
Yeah.
Can we use Arc Flash mitigation systems, for example, or do remote switching operations to kind of bring that risk right down, and then protect the wearer in the instance?
I would thank you very much, Anthony.
Yeah,
If I would